So what's OOP and what are the alternatives? Years ago, probably more than 20 years ago, people used stepwise design, also known as top-down design, much more frequently than OOP. It was just being invented. OOP handles complexity very well, which we'll find out in a minute. Top-down design is a very good process, but it's usually for smaller teams. OOP and OOD decompose a problem the same way that stepwise design does, but it has some subtle differences that allow people to divide out work. There were some others as well, but they've mostly been disregarded now. So let's look at a typical scenario for object-oriented design and programming, as opposed to top-down design. Now, if you think of years ago a small team working on top-down design on one system, there might have been one very, very large program, a bit like this. And if it was a program about reports and grades and teachers and a school admin system, for example, then maybe the bit that dealt with students would be, mostly this bit here. But there might also be a function here which deals with students, and maybe a little bit of this function also had to do with students, and some variables at the very, very end. So really, each one of these people had to know the system quite well if they were going to work on it. And the larger that team became, the more difficult it was, and also the larger that system became, the more difficult that was for everybody to know it at the same time. And if one person made any changes here, it could affect what someone else was doing on the same program. Then came object-oriented design. For larger teams particularly, it might happen that these teams are distributed in different parts of the world, for example in different countries, even different time zones, and that maybe these people here are interested or only working on the student part. These people here are only interested in the reports and working on the school reports part. Maybe these people here are only interested in the timetabling system. And because each of these is a self-contained class or program, which has its own variables and its own functions, each of these teams only needs to understand his own area. And it can be divided out quite well because you can work on your own area without affecting anybody else, and you don't need to understand what anyone else knows. You just need to know it's there and how to call it. Now, if you're making an object-oriented design, which you're then going to program in an object-oriented programming language, the first thing you have to do is decide what are the objects going to be. What things work together in real life in your current system to solve the problem. Then you've got to find out what their properties are, or in other words, what sort of things do they have. And finally, the interaction between them. So you decide how do these objects work together, using their properties and their actions, to solve the problem. An example of this might be in the student's grade system that we mentioned earlier. If I wrote down a description of exactly what I expected the system to do, and I started off by circling the nouns, so I might have grades, students, class, name, number, report, and semester. So each one of those is a potential class in my system, and that class, even if one of these isn't a class, it'll be the property of a class or a variable inside a class. Then I need to look at actions. So I'm going to look at verbs next. So I'm going to say entered. I'm going to underline these: saved, searched, printed. That's about it. So everything that I've underlined is going to be an action in one of the classes. Everything that I agree is big enough to have its own class is probably going to be a class. Semester, report, possibly not name and number because they're probably properties of one of those classes of this. But this is how I generalize and how I make a list of potential classes and potential actions for them, and then later on I relate them together, kind of like this. We have a report which contains students and grades, and a student is contained within a class. Many students are within one class. A teacher is associated with a class, and a student can have many grades. Whenever we're drawing this and we're writing them out, we normally use a UML class diagram which shows the relationships between classes, but we'll look at that a little bit later on. Now, this makes it really easy for a team to break up the work, because you might have, for example, 5 teams, and each could work on a different area. They could be in different parts of the world, different time zones, and the real thing is that the group here who works on reports may not need to understand the class student or the class grade or the class teacher or the class. They may only need to know the public methods and public variables that they're going to use. Finally, another advantage is that using inheritance and polymorphism, for example, a student can inherit a lot of code from a class person, and that same code can be inherited by a class teacher because they're both people. So possibly a small percentage of the code in each of those two classes, student and teacher, can be taken from a person. This means it's reusable and it's maintained in only one place. And if it needs to change, it can be changed easily in one place. So let's summarize and let's find out exactly what those characteristics were again. OOP has, well, first of all, there are many different potential design processes. OOP is just one of them, but it has become very, very, very popular recently because it simplifies complexity and it allows work to be split up between different teams very easily. It's good at handling large, complex systems like the one we've just described. And it's very, very good because different teams and sub-teams within them only need to know the bits that they're working on. And the rest of it can be hidden because you don't really need to know it. It's a good solution for simple problems, well, for complex problems. It's not a very good solution for simple problems because it may be a little bit like cracking open a walnut with a hammer. There are small programs and small systems that aren't very complex and don't really need OOP. They can be solved very, very quickly with simple traditional methods. And finally, one disadvantage of OOP is that it takes time to understand, whether you're designing the system or programming it.